Hello everyone, in this video we're going to explore topic 10.13 radius and interval of convergence of power series. Alright, so in previous topic we learned how to expand the Taylor polynomials, right? So remember e to the s can be expressed as this guy right here, right? So this guy right here is called a power series, right? Now we're going to talk about the definition of power series. If S is the variable, then an infinite series of the form series a sub n s to the n, when n goes from 0 to infinity, equals, substitute 0 for n, we get the first term, 1 for n, we get the second terms, etc. Right? This one is called a power series. More generally, an infinite series of the form a sub n times s minus c to the n. Alright? If n equals 0, we get this guy. N equals 1, we get the second one, etc. Right? It's called a power series center SC, where C is a constant. The first one, center equals 0. Right? Now, let's take a look at the first example. State the values of C where each power series is centered. Alright, so we just rewrite this one as the series s minus 0 raised to the n over n factorial, right? When n goes from 0 to infinity, right? So, in this situation, we're gonna match this guy and this guy up, right? So we have s minus c, right? So that means c equals 0, right? Now same thing, we have s minus c, right? So we just match this guy up. So c equals -1, right? Now we have s minus c, right? Match this guy up. So c equals 1, right? Now we're going to talk about the radius and interval of convergence. There are three types of convergence of a power series. The first one, the power series converges at a single point. That's called the center. The second one, the power series converges at an interval. Right? It's going to be center right here. Right? Go to the right, you add r. Go to the left, you subtract r. Right? R is called the radius of convergence. Number 3, the power series converges on the entire real number line. Right? So it could be the whole thing right here. Now we're going to talk about the theorem of convergence of a power series. For a power series center SC, precisely one of the following is true. Number 1, the series converges only at the center. Number 2, there exists a real number r greater than 0, such that the series converges absolutely for absolute value of s minus c less than r. Now we're going to expand this one. It turns out to be s minus c less than r, or greater than -r, right? Now I'm going to add c 3 sides, so I'm going to end up with c minus r less than s less than c plus r, right? And we look at this one right here, it's actually this guy right here, right? And diverges for absolute value of s minus c greater than r. This guy is the same thing as s minus c greater than r, or s minus c less than -r. Number 3, the series converges absolutely for all values of s, right? The number r is called the radius of convergence of a power series. Now, if the series converges only at the center, the radius of convergence is 0. If the series converges for all values of s, the radius of convergence is infinitive. The set of all values of s for which the power series converges is the interval of convergence of the power series. Alright, so this theorem right here is extremely important. Alright, now we're going to apply this theorem into the example number 2. Find the radius of convergence for each power series. Question A. We need to use the ratio test, right? So we're going to set up the limit a sub n plus 1 over a sub n when n approaches infinity, right? So it's going to be limit when n approaches infinity of absolute value of n plus 1 factorial times s raised to the n plus 1 over n factorial times s raised to the n, right? Now we're going to simplify this one, so it could be limit when n approaches infinity absolute value of n plus 1 factorial can be written as n plus 1 times n factorial. So this guy cancel out, right? So you have n plus 1 left right here. Now this guy cancel out, you have s left right there, right? Over 1, right? So it's going to be limit when n approaches infinity. Now s not related to this one, I bring it to the front, right? So it could be absolute value of s right here. Absolute value of n plus 1, right? So it's going to be absolute value of s times infinity, right? So we conclude that the limit is infinite for all s different from 0. So the series diverges for all s different from 0, right? Now when s equals 0, the series becomes n factorial times 0 raised to the n, right? So it could be 0, which is convergent, right? Therefore, the series converges only at s equals 0, and the radius of convergence is 0. Now let's move on to question B. We need to set up the limit, right? So it could be limit when n approaches infinity of absolute value of a sub n plus 1. It could be 3 times s minus 2 raised to the n plus 1 over a sub n. It could be 3 times s minus 2 raised to the n, right? Now 3 and 3 cancel out. This guy cancel out. You only have limit when n approaches infinity of absolute value of s minus 2, right? So it could be absolute value of s minus 2, right? Now, in order for this one to be convergent, this one must be less than 1, right? So we have s minus 2 less than 1 greater than negative 1, right? Now, we're going to add 3 sides. So it could be 1 less than s less than 3, right? Now, we're going to draw the number line. This one is the center, right? The center equals 2 right here, right? And then 3 right here, 1 right here. The distance from here to here is the radius, right? This is the radius. So the radius of convergence is 1, right? Now question C, same thing, right? We need to set up the limit absolute value of negative 1 raised to the n plus 1 times s raised to the 2n plus 1 like this over 2 parentheses n plus 1 and then plus 1 altogether factorial, right? Divide by a sub n, right? A sub n is this one, right? So we just check reciprocal of this one. So it could be 2n plus 1 factorial over negative 1 raised to the n times s raised to the 2n plus 1. Alright. Now, negative 1 raised to the n plus 1 can be written as negative 1 raised to the n times negative 1, right? This guy right here can be written as raised to the 2n plus 3, right? And then this one is going to be s raised to the 2n plus 1 times s squared, right? Now this guy can be written as 2n plus 3 factorial, right? So it can be 2n plus 3 times 2n plus 2 times 2n plus 1 factorial, right? Now we're going to simplify. Negative 1 raised to the n and negative 1 raised to the n gone, right? When you take absolute value of negative 1 right here, it becomes positive, right? So this guy gone. S raised to the 2n plus 1 right here and s raised to the 2n plus 1 right here cancel out, right? You only have s squared left, right? So we have limit of absolute value of s squared, right? When n approaches infinity. Now 2n plus 1 factorial and 2n plus 1 gone. You have this guy on the bottom, right? Now this guy right here, not related to n right here, I bring it to the front, right? So have absolute value of s squared. Limit of 1 over 2n plus 3 times 2n plus 2, right? Don't forget to put this guy inside the absolute value side when n approaches infinity, right? Now n approaches infinity, this guy approaches 0, right? So 0 times s squared is going to be 0, right? 0 less than 1, right? So by the ratio test, this series converges, right? So we have radius is infinity. Now let's move on to question D. We're going to do exactly the same thing, right? We're going to set up the limit 2 parentheses n plus 1 factorial, right? Times s raised to the 2 parentheses n plus 1 over n plus 1 factorial, right? Multiply by this one reciprocal, right? Remember a sub n plus 1 over a sub n, right? We're going to use the ratio test. So it could be n factorial over 2n factorial s raised to the 2n, right? When n approaches infinity. We're going to simplify this one. It's going to be 2n plus 2 factorial, right? So 2n plus 2 is going to be 2n plus 2 times 2n plus 1 times 2n factorial, right? Now this guy is going to be s raised to the 2n plus 2, right? And it's turned out to be s raised to the 2n times s squared, right? Now this one right here can be written as n plus 1 times n factorial, right? Now you have 2n factorial right here and 2n factorial cancel out, right? So we have limit when n approaches infinity, absolute value of, you have 2n plus 2 times 2n plus 1 left on the top, right? Now this one, this guy equal this guy, right? So you have s to the 2n and s to the 2n cancel out. You have s squared left, right? So s squared not related to this one, right? So I put absolute value of s squared in the front, right? Now you have n factorial right here and n factorial right here, right? So you have n plus 1 on the bottom, right? Now when n approaches infinity, the degree on the numerator is n squared, right? Degree on the denominator is just n, right? So this guy bigger than this one, the limit approaches infinity, right? So you have absolute value of s squared times infinity, right? So it's going to be infinity if s not equal to 0, right? So the series converges at s equal 0. And 0 is the center of this series right here, right? Because you can rewrite this one as s minus 0 raised to the 2n, right? Then by the theorem above, the radius of convergence is 0, right? Now, when you find the interval of convergence, you must check the endpoints. So previously, we didn't check the endpoints until we learned this one right here, alright? So we have 6 different forms. First, the radius is 0 because it's convergent at the center C, right? The radius is infinity, which means the series converges on the real number line, right? The radius is R, right? You have the interval convergence, right? You have the open interval, right? You have the half closed interval right here, right? You have half closed interval right here, or you have the closed interval right here, right? Now, example number 3, we're gonna find the interval of convergence for each power series, right? By the way, we're gonna find the radius of convergence, right? So we're gonna use the ratio test, right? So we have limit absolute value of s raised to the n plus 1 over n plus 1 times this one reciprocal is gonna be n over s raised to the n, right? When n approaches infinity, right? Now we're gonna simplify this guy, right? So we have s left right here, right? We can print s to the front, right? So absolute value of s times limit of absolute value of n over n plus 1, right? When n approaches infinity, right? And then when n approaches infinity, number 1 right here doesn't really matter, right? So we have n over n, which means 1, right? So this is why I have absolute value of s, right? Now, in order for this one to be convergent, you need absolute value of s less than 1 by the ratio test, right? So then it's going to be -1 less than s less than 1, right? So this one is the interval of convergence for this power series, right? We're not going to stop right here. Be careful. We need to check the end points, right? We need to check this guy and this guy, right? Now, case number 1, s equals -1, right? So then we substitute -1 for s back to the original series right here. So we have -1 raised to the n over n when n goes from 1 to infinity. This guy actually alternating harmonic series, right? So it can be convergent. Now we're going to check the second case. S equals 1. So the series becomes 1 power of n over n when n goes from 1 to infinity. Now 1 power of n is actually 1, right? So I don't need this one, right? Now this guy divergent because this one is the harmonic series, right? Now we're gonna conclude. So we just rewrite this one. -1 less than s less than 1, right? We check the endpoints. This guy works, right? So we need to include the equal sign right here, right? This one doesn't work. We ignore it, right? So the answer is right here. This one is the interval of convergence for the power series, right? Now let's move on to question B, right? So we're gonna do the same thing, right? We're gonna set up the limit absolute value of -1 raised to the n plus 1 times s plus 1 raised to the n plus 1 over 2 raised to the n plus 1 divided by this one reciprocal, right? So 2 raised to the n over -1 raised to the n times s plus 1 raised to the n when n approaches infinity, right? Now we're gonna simplify this one, right? -1 raised to the n and -1 raised to the n cancel out. You have -1 raised to the first left, right? So when you take absolute value, it's gonna be positive, right? So I don't worry about this one anymore, right? Now this guy and this guy cancel out. You have s absolute value of s plus 1 left on the top, right? I bring it to the front, right? I put limit when n approaches infinity right here, right? 2 to the n, and it's 2 to the n plus 1, so I have absolute value of 1 over 2 left, right? So we have absolute value of s plus 1 over 2, like that, right? And then by the ratio test, this one convergent if this one less than 1, right? So then I'm going to multiply both sides by 2. So it could be absolute value of s plus 1 less than 2, right? It's going to be the same thing as negative 2 less than s plus 1 less than 2, right? I'm going to subtract 1 3 sides, so I'm going to end up with negative 3 less than s less than 1, right? Now I need to check the endpoints right here, right? So first case s equals negative 3, right? Substitute negative 3 for s back to the original one right here. So you're going to end up with the series negative 1 raised to the n times negative 3 plus 1 raised to the n over 2 raised to the n when n goes from 0 to infinity, right? Alright, so this guy is the same thing as negative 1 raised to the n. This one is negative 2 raised to the n, right? So I can combine them, right? It becomes 2 raised to the n, right? Over 2 raised to the n when n goes from 0 to infinity, right? And then this one equals, this series diverges by geometric series test because the common ratio is 1, right? Now we're going to check s equals 1. So the series becomes negative 1 raised to the n times 2 raised to the n over 2 raised to the n, right? When n goes from 0 to infinity, this guy cancel out, so it could be negative 1 raised to the n left right here, right? And this one diverges by geometric series because common ratio equals negative 1, right? Final answer is just this guy right here, right? Now let's move on to question C. So we're going to set up the limit, right? A sub n plus 1, it could be s raised to the n plus 1 over n plus 1 square times n square over s raised to the n, right? When n approaches infinity. So we're going to simplify this one. S raised to the n plus 1 and s raised to the n cancel out. We have s left, right? So absolute value of s outside. Limit when n approaches infinity of n square over n plus 1 altogether square, right? Now when n approaches infinity, you can remove number 1 right here by relative growth rate, right? So you have n square over n square is going to be 1, right? So you end up with absolute value of s, right? Now you need this one to be less than 1 so that the series converges, right? So then it's going to be the same thing as negative 1 less than s less than 1, right? Now you need to check the endpoints, right? So s equal negative 1. Substitute negative 1 for s back over here. So you have the series negative 1 raised to the n over n square, right? When n equals 1 to infinity, right? Now this one converges by alternating series tests, right? Now we're gonna check s equals 1. So we have the series 1 over n square. This one still converges by p series because p equals 2, right? Greater than 1. Alright, so finally the interval of convergence is negative 1 to 1. And you need to include the endpoints, right? Right here. This one is the final answer. Alright, now let's move on to question D. we do exactly the same thing. We're going to set up the limit, right? Absolute value of -1 raised to the n plus 2 times s minus 2 raised to the n plus 1 over n plus 1 times 2 raised to the n plus 1, right? Times reciprocal of this one, it could be n times 2 raised to the n over -1 raised to the n plus 1 times s minus 2 raised to the n, right? When n approaches infinity. Now this guy cancel out and you have -1 left. So when you take the absolute value of -1, it's going to be 1, right? Now this guy cancel out, you have s minus 2 on the top left, right? So we have the limit when n approaches infinity of absolute value of s minus 2 right here, right? N on the top and n plus 1 on the bottom, right? So we have n right here, n plus 1. 2 to the n and 2 to the n plus 1, you have 2 on the bottom, right? Now when n approaches infinity, this guy right here approaches 1, right? By relative growth rate, you can eliminate 1 right here. So n divided by n is going to be 1, right? So you're going to end up with s minus 2 over 2 absolute value, right? We need this one to be less than 1 so that the series converges, right? Now we're going to multiply both sides by 2. So we have absolute value of s minus 2 less than 2, right? This one the same thing as -2 less than s minus 2 less than 2. Add 2 three sides, so you have 0 less than s less than 4, right? Now we need to check the endpoints, right? So s equals 0. The series becomes, now we're going to simplify this one, so this one turns out to be the series -1 raised to the n times -1 raised to the first, right? So it could be -1 raised to the n times -2 raised to the n times -1, right? Over n times 2 raised to the n, right? So this guy right here, you can combine, it's going to be 2 raised to the n, right? So this guy cancel out, right? So you're going to end up with the series -1 over n, right? When n goes from 1 to infinity. This one diverges by the harmonic series, right? Now we're going to check s equals 4. So we substitute 4 for s back to the original series. So we're going to end up with the series n goes from 1 to infinity of -1 raised to the n plus 1 times 2 raised to the n over 2 raised to the n times n, right? This one cancel out, right? So we're going to end up with the series -1 raised to the n plus 1 over n when n goes from 1 to infinity, right? This series converges by alternating series test, right? So we're going to conclude the interval of convergence is 0 less than s less than 4, right? We need to include the endpoint right here, right? So this one is the final answer. Now let's move on to question E. We're going to set up the limit of absolute value of 2 parentheses n plus 1 factorial, right? Times s over 3 raised to the n plus 1 divided by 2 n factorial times s over 3 raised to the n, right? So this guy turns out to be limit when n approaches infinity of absolute value of 2n plus 2, right? Factorial. Now s over 3 raised to the n plus 1, s over 3 raised to the n cancel out. You have s over 3 left on the top, right? The bottom is 2n factorial. So this guy turns out to be limit when n approaches infinity the top becomes 2n plus 2 times 2n plus 1, right? And then you have 2n factorial cancel out, right? Times s over 3. Now when n approaches infinity, this guy approaches infinity, right? So the series only converges at the center. The center of this series is 0, right? Differentiation and integration of power series, right? So if you given the power series right here, you can take derivative of this one, right? So we're gonna use the power rule. We can bring n to the front, right? And subtract 1. We're gonna end up with this guy right here, right? Similarly, you're gonna take antiderivative of this one using the power rule again, right? So you have 1 over n plus 1, right? This one, okay, and the power right here should be n plus 1, right? And when you take antiderivative, don't forget to add the constant c, right? Now the radius of the convergence of the series obtained by differentiating and integrating a power series is the same as that of the original power series, right? However, the interval of convergence may differ as a result of the behavior of the endpoints. Alright, let's take a look at this activity. Question 1. Given the series right here, write out an expression that includes the first 5 terms of the series, right? Now substitute 0 for n. So it could be s power of 0, it could be 1. 1 over 0 factorial, it could be 1, right? Remember 0 factorial equals 1 factorial and equals 1, right? So 1 divided by 1 is going to be 1. N equals 1 is going to be s power of 1 over 1 factorial is still 1, right? So you have s left. N equals 2, you have s squared over 2 factorial plus s cubed over 3 factorial, right? Plus s to the 4 over 4 factorial, right? The first 5 terms we can stop right here, right? Plus etc. Now question 2, find derivative of this series, right? So f prime of s equals derivative of 1 equals 0, right? Derivative of s equals 1, right? Bring 2 to the front, you have plus 2s over 2 factorial plus 3s squared over 3 factorial plus 4s cubed over 4 factorial, right? Plus etc. plus the general terms is going to be right here. Bring n to the front, right? So it could be n s raised to the n minus 1 over n factorial, right? Now we're going to simplify this one, right? So we have 1. 2 factorial is going to be 2, so it's going to be s, right? 3 factorial is going to be 6, right? So it's going to be s squared over 2 plus 4 factorial is going to be 24, right? So we have s cubed over 6, right? 6 which means 3 factorial, right? And right here I can put 2 as a 2 factorial, right? Plus etc. Now question 3, what do you notice about f of s and f prime of s? Actually they're both the same, right? So we have f of s equals f prime of s, and then the function should be f of s equals e to the s, right? Because when you take f prime of s, it's still e to the s. They're both the same, look, right? Now let's move on to example number 4. Interval convergence for f of s, f prime of s, and antiderivative of f of s. Alright. Find the intervals of convergence for each of the following f of s first, right? We're going to use the ratio test, right? So we have limit of absolute value of s raised to the n plus 1 over n plus 1 times n over s raised to the n, right? When n approaches infinity, right? Now s raised to the n plus 1 and this one cancel out, you have s left, right? So it could be limit of absolute value of s when n approaches infinity. This guy right here equals 1, right? So it could be absolute value of s only. So it could be absolute value of s, right? Now, in order for this one to be convergent, you need absolute value of s less than 1, right? Or -1 less than s less than 1, right? Now, we're going to check the endpoints, so s equals -1, right? Substitute -1 for s back to original 1. We have a series -1 raised to the n over n. When n goes from 1 to infinity, this series converges by alternating series test, right? Now, check s equals 1. So you have the series when n goes from 1 to infinity of 1 raised to the n is going to be 1 over n, right? This series diverges by harmonic series test, right? So final answer is you're gonna include -1, right? So it should be -1 less than or equal to s less than 1 only. Now question B, we need to check f prime of s, right? So we're going to use this one to take the derivative, right? So it could be series when n goes from 1 to infinity of n times s raised to the n minus 1 over n, right? So then it's going to be the series when n goes from 1 to infinity of s raised to the n minus 1 only, right? Now we're going to use the limit of a sub n plus 1 over a sub n, right? So a sub n plus 1 of this one should be s raised to the n over a sub n is going to be s raised to the n minus 1, right? When n approaches infinity. So it's going to be limit when n approaches infinity of absolute value of s, right? And then in order for this one to be convergent, you need this guy less than 1, right? So then you have -1 less than s less than 1, right? Again, you need to check the endpoints, right? Now I'm going to check s equals -1 first, right? So we have the series when n goes from 1 to infinity of -1 raised to the n minus 1, right? And this one diverges by the n terms test or divergent test, right? Now we're going to check s equals 1. So it turns out to be the series n goes from 1 to infinity of 1 raised to the n minus 1. Alright, it's still the same, right? It still diverges by the n term test or divergent test, right? So finally, your answer should be this one only, right? Now question C. We're gonna take n time derivative of this one. So it could be the series n goes from 1 to infinity of s raised to the n plus 1 over n plus 1 times n, right? Now we're gonna use the ratio test, right? So we're gonna have limit absolute value of a sub n plus 1 over a sub n, right? So it could be s raised to the n plus 1 is going to be plus 2 over n plus 1 times n plus 2, right? Times reciprocal of this one, n times n plus 1 over s raised to the n plus 1, right? When n approaches infinity. Alright, we're going to simplify this one. It's turned out to be limit when n approaches infinity of absolute value of s, right? And then n plus 1 cancel out. You have n over n plus 2, right? When n approaches infinity, this guy right here approaches 1, right? So it's going to be absolute value of s left, right? And we need this one to be less than 1 so that the series convergent, right? So we have s less than 1 greater than -1, right? We need to check the endpoint, so s equals -1. Substitute back over here. So we have the series n goes from 1 to infinity of -1 raised to the n plus 1 over n times n plus 1, right? And this series converges by alternating series test, right? Now, s equals 1. So we have the series 1 raised to the n plus 1 is going to be 1, right? 1 over n times n plus 1. When n goes from 1 to infinity. This series converges by direct comparison test, right? Because you can directly compare this one with the series 1 over n squared, right? But this series converges by p series, right? So final answer is this one works, so we need to include the endpoints, right? So it could be -1 less than equal to s less than equal to 1. This one is the interval of convergence, right? Now let's move on to example number 5. The radius of convergence for the power series is equal 1. What is the interval of convergence? Alright, so we know that the center C equals 4, right? Right here. The radius is 1, right? So you have the formula absolute value of s minus c less than the radius, right? So we're going to substitute value, so absolute value of s minus 4 less than 1, right? This one is the same thing as s minus 4 less than 1 but greater than -1, right? So add for 3 sides, so it could be 3 less than s less than 5, right? Now we're going to check the endpoints. So if s equals 3, substitute 3 for s back to the original power series. So we're going to end up with -1 raised to the even power. It could be positive, right? So it could be the series 1 over n when n goes from 1 to infinity, right? And this series diverges by harmonic series test, right? Now s equals 5 and then the series becomes, so it's gonna be 1 over n, and this guy the same thing, diverges by the harmonic series test. So the answer is just this guy. Now let's move on to example number 6. If the power series converges s equals 8 and diverges s equals 10, which of the following is true? Alright, so we're going to draw the number line. We're going to label from 0 to 10. S equals 8, the series converges. You know that at s equals 10, the series diverges. You know that center is 5. So then the radius of convergence could be between the distance from here to here, 3, right? But less than 5, right? Now you're pretty sure that this one is the radius, right? So you're gonna count to the left 3 units, right? 4, 3, 2, so it could be right here. So this interval right here is called the interval of convergence. You're pretty sure that. But you don't know if the series converges at s equals 2, right? The endpoints. You don't know a sub n. So you cannot check this one, right? So number 1 right here, wrong, right? Maybe true, maybe false, right? Now number 2, the series converges s equals 3. Yes, 3 is inside of the interval of convergence right here. Number 2, correct. Number 3, the series diverges at s equals 0. You actually don't know if these values make the series converge or diverge, right? So this one wrong. So the answer should be B. Now let's move on to example number 7. The coefficients of the power series satisfy a sub 0 equals 6. A sub n equals this for n greater than or equal to 1. What is the radius of convergence? Alright, so I'm gonna call this one B sub n, right? In order to find the radius of convergence, I need to use the ratio test, right? So I have limit absolute value of b sub n plus 1 over b sub n when n approaches infinity, right? So it's going to be limit when n approaches infinity absolute value of a sub n plus 1 times s minus 3 raised to the n plus 1 over a sub n times s minus 3 raised to the n, right? Now, you don't know a sub n plus 1, you don't know a sub n, but you given this one right here, right? So we're going to use this guy right here. You have a sub n equals this guy times a sub n minus 1. Now, if we take a sub n plus 1, so what happens? Does that mean it's going to be 2 times n plus 1 on the top, right? Over 3 times n plus 1 on the bottom, right? Times a sub n, right? Now divide both sides by a sub n and simplify the 1 right here. So it's going to be a sub n plus 1 over a sub n equals 2n plus 3 over 3n plus 4, right? So I'm going to substitute this ratio right here back over here, right? So I'm going to have limit when n approaches infinity absolute value of 2n plus 3 over 3n plus 4, right? Times, you're going to simplify this and this, you have s minus 3 left, right? Now, when n approaches infinity, we're going to use the relative growth rate, right? We can ignore this and this, right? So then, we're going to simplify n and n. The answer is 2/3, right? So, it could be 2 over 3 times s minus 3, right? Put this guy inside absolute value, right? So, in order for this series to be convergent, this guy must be less than 1, right? So we have 2 over 3 absolute value of s minus 3 less than 1. This guy is the same thing as, now multiply 3 sides by 3.5, right? And add 3 sides. So you're going to end up with 3 over 2 less than s less than 9 over 2, right? So we're going to draw the number line, right? So we have, this one is 3 over 2. This one is 4 over 2. 5 over 2. 6 over 2. 7 over 2. 8 over 2. And finally, 9 over 2, right? And observe that the center is right here, right? The distance from here to here is the radius, right? So radius is 9 over 2, subtract 6 over 2, it could be 3 over 2. And this one is the final answer. Now let's move on to example number 8. The radius of convergence for the power series is 5. What is the intervals of convergence? Alright, so we have the radius is 5, right? We have the center right here is 5, right? And we have the formula absolute value of s minus c less than or, right? Substitute value, so you have absolute value of s minus 5 less than 5, right? It's going to be the same thing as s minus 5 less than 5 greater than negative 5, right? Now you're going to add 5 3 sides, so it could be 0 less than s less than 10, right? Now we need to check for the end points, right? 0 and 10 right here. S equals 0, substitute 0 for s back to the original series. You're going to end up with n equals 1 to infinity of negative 1 raised to the n plus 1 times negative 5 raised to the n over n times 5 raised to the n. It's going to be the series -1 raised to the n plus 1. -5 right here can be written as -1 raised to the n times 5 raised to the n, right? Over n times 5 raised to the n, right? Now you can combine these two guys right here, right? So it can be -1 raised to the 2n plus 1, right? And this guy cancel out, right? So it's gonna be the series -1 raised to the 2n plus 1 over n, right? And you're pretty sure that 2n plus 1 is odd, right? So -1 raised to the odd power is going to be -1, right? So it could be the series -1 over n, right? And this guy actually harmonic series multiplied by -1, right? But harmonic series always diverges, right? Now we're going to check the endpoint s for 10. Substitute 10 for s over here. So we have the series -1 raised to the n plus 1 times 10 minus 5, it could be 5 raised to the n over n times 5 raised to the n. This guy gone, right? So you're going to end up with the series -1 raised to the n plus 1, right? Over n. Now if n is odd, and then this guy becomes even, and this becomes 1. If n is even, and then this guy right here becomes odd, and then the whole thing right here becomes -1, right? So this one actually alternating series, right? Specifically, this guy actually alternating harmonic series, right? So we're gonna let bn equals 1 over n, right? So we're going to use alternating series test, right? So we're going to find the limit of 1 over n when n approaches infinity. It's going to be 0, right? Moreover, you see that the series 1 over n decreasing as n increasing, right? You're going to include 10 only, right? You exclude s equals 0, right? So the answer must be D. Now let's move on to example number 9. Let a sub n equals 1 over n ln of n. For n greater than or equal to 3, let f be the function given by fs equals 1 over s ln s. So this guy is the representation of this guy, right? Now the function f is continuous, decreasing, and positive. Use the integral test to determine the convergence or divergence of this series, right? So we're going to review the integral test. It's going to be right here. Suppose fs is positive, continuous, and decreasing on this interval. If this improper integrals convergence, so is the series. If this improper integrals divergence, so is the series, right? Now k in this situation is 3, right? So we have the integral from 3 to infinity of a sub n. It's going to be this guy right here, right? 1 over s ln s, right? Alright, so it's going to be limit when b approaches infinity of the integral from 3 to b 1 over s ln s ds, right? Now we're going to use u substitution, right? So we're going to let u be ln s, then du equals 1 over s ds, right? We're going to change the lower bound and upper bound, right? So we substitute over here. We have limit when b approaches infinity integral from ln 3 to ln b of 1 over u du, right? So then it's going to be limit when b approaches infinity of ln absolute value of u evaluated from ln 3 to ln b, right? So it's going to be limit when b approaches infinity of ln absolute value of ln b, right? Subtract ln absolute value of ln 3, right? Now when b approaches infinity, this guy approaches infinity, subtract ln of absolute value of ln of 3, right? So it's going to be infinity, right? Which is diverges by integral test. Find the interval of convergence of the power series right here, right? So we're going to use the ratio test, right? So we're going to take the limit of absolute value of a sub n plus 1 over a sub n when n approaches infinity. So it's going to be limit when n approaches infinity of absolute value of s minus 2 raised to the n plus 1 plus 1, it could be n plus 2, right? Over n plus 1 times ln of n plus 1. Divide by this one, which is you're going to multiply this one reciprocal, right? So it could be n ln of n over s minus 2 raised to the n plus 1, right? Now we're going to simplify this one, so we have limit when n approaches infinity of absolute value of this guy, simplify. You have s minus 2 on the top left, right? Times n over n plus 1, right? Times ln of n over ln of n plus 1. Alright, now when n approaches infinity, this guy right here approaches 1, right? This guy right here you just rewrite, right? So we have limit when n approaches infinity of absolute value of s minus 2 times ln of n over ln of n plus 1, right? Now I'm going to do this one on the side, right? So I'm going to take limit when n approaches infinity of ln of n over ln of n plus 1, right? When n approaches infinity, this guy approaches infinity over infinity. So this one is the indeterminate form, right? So I need to use the last bit of rule, right? So it's going to be limit when n approaches infinity of 1 over n over 1 over n plus 1, right? So it's going to be limit when n approaches infinity of 1 over n times n plus 1 over 1, right? So it could be limit when n approaches infinity of n plus 1 over n, right? We're going to use the relative growth rate, right? So it could be limit of n over n when n approaches infinity, it's going to be 1, right? So finally, you're going to end up with absolute value of s minus 2, right? And in order for this power series to be convergent, this guy must be less than 1 by the ratio test, right? So it could be s minus 2 less than 1 greater than negative 1, right? At 2 3 sides, so it could be 1 less than s less than 3. Now, we need to check the endpoints, right? Now, s equals 1. Substitute 1 for s, so the series becomes. Now, this series converges by alternating series test. I'm going to leave this one for you to check, right? Now, we're going to check s equals 3. Then the series becomes. And then this guy becomes the series 1 over n ln of n, right? Now we're going to use the integral test to check to see if this series convergent or divergent, right? Which we did before right here, right? And it can be diverges by integral test, right? So s equal 3 doesn't work, right? But s equal 1 works, right? So finally, The interval of convergence is 1 less than equal to s less than 3. Right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young, it has just begun as she puts her hand